Okay, example 9 is also at Excel, and it brings us to another concept. So packaging plants fill bags with cement. The weight X of a bag of cement can be modelled by a normal distribution with mean 50, standard deviation of 2. So I might just make that note here. Mean equals 50, standard deviation equals 2. Find the probability that X is greater than 53. The probability that X is greater than 53, again in the normal distribution, we're now relying on our calculator, unless of course this is nice. So I might remind you of how to do the integration here. If we needed to do this through integration, we would want the probability that's greater than 53 means a lower bound of 53, an upper bound of infinity, and our function is 1 over, and because we've got a standard deviation of 2, it's 2 root 2 pi, because we're talking about x scores, e to the negative half x squared, but remember z is equal to x minus mu over sigma, so we now just put in, instead of z squared, we put in x minus 50 over 2 squared, or we convert to z scores and we do it that way. And actually converting to z scores would be pretty easy here, because 53 is 1.5 standard deviations above, so that would have been an easier way of doing it. But I just want to remind you that this can be done using raw scores if you transform the function. Got a little dx there, of course. So we could do this in our calculator. Before we do it, I might just quickly get the answer while I'm in NCD here and show you that we get the same answer both ways. So NCD is lower bound 53, upper bound infinity, and the upper bound can just be something enormous, so I'll just make it 1,000. That's out there, that's close enough to infinity for the purpose of this context. My standard deviation was given to me as 2, and my mean was given to me as 50. Close brackets, this is 1.5 standard deviation above, and that's the lower bound. So I'm expecting an answer that's below 16 and above 2.5. Somewhere in the middle, probably closer to 2.5. And I get 6.7, so 0.067 or 0.0668. And now let's just check that using that other method, which is if I go back to here and calculate, oops, it's right there, my apologies, there it is there, take the square root of, and the function is 1 over, and this can all be done quite quickly, times shift square root 2 shift pi, so you haven't got a lot of time in your exam, times by shift e to the power of, now I'll put my little function, my little fraction there, put a negative in front, negative a half, I'm just going to leave it like that, I'm not going to transform the inside, I'll do that in here. This is going to be x, well actually it's going to be a fraction, and on top it's going to be x minus 50, on the bottom it's going to be over the standard deviation 2, close brackets and square it, and then I'll do it in the boundary from 53 to infinity, which I'm just calling 1,000 today, and 0.0668, same thing again. So you can do it using that integration process as well. And there's my answer to part A. Should probably write that, part A. Part B, find the weight that is exceeded by 99% of the bags. So for this one, I'm going to do a little bit of interpretation. I want 99% of the bags to exceed a weight. So it's going to be something down here such that 99% of the bags are above. And I want that score, that X score. But what I could do, I'll show you another method now, is it's sometimes easier to work out the Z score and then work from there. So I'm going to calculate the Z score that has 99% above and then convert it into an X score. And if you use normal inverse distribution, that is one way of doing it. But if I do solve n, exit, stat, distribution, normal CD, I want my lower bound to be X, and I want my upper bound to be infinity, which I'm going to call 1,000, and I'm going to do it for 1, 0. So I'm calculating a Z score now, and I want that to be equal to 0.99, and then I put comma, solve that for X, close brackets, and that should give me an answer, negative 2.3263. So Z equals negative 2.6223 63, and therefore x will be equal to negative 2.6263 times by 2, the standard deviation, plus 50. And that's going to be equal to, that's basically 5.242526 off 50, so it will be 44.7474. And I may have that slightly wrong. Let's hope I got that calculation correct. But either way, you can put that in your calculator. I've taken it away from 50. And if 50 is my median here, my lower bound is going to be somewhere down there, a couple of standard deviations below. So that's one way of doing B. And then question C, this now converts into a binomial probability question. So this is where it gets a bit interesting and a bit trickier. 3 bags are selected at random. Find the probability that 2 weigh more than 53 and 1 weighs less than 53. So we know, let's say P, our probability of success, is equal to the probability that X is greater than 53. So we'll say greater than 53 is success, and of course this is equal to 0.0668. That's come from there. We've already done that, greater than 53. And we want the probability that, we'll call it function y equals 2, and we're going to define over here y is approximately equal to the binomial distribution, 3 events, probability of success, so this is a bit of a hark back to binomial stuff, 0.0668 coming from there. And so probability of y equals 2 is 3c2 times by 0.0668 squared times by 1 minus 0.0668, whatever that is, and that's just to the power of 1. And so I can go back into my calculator now and do that calculation, but I do need to get into my probability menu, so I exit out of here, exit, just to remind you,